Hi, John at Basics here. In this video I'm going to be working through the decimal to binary worksheet and showing you how I'd solve the questions. If you haven't seen the decimal to binary video or tried the worksheet already, maybe pause the video and go and do that first. In question 1, we're just converting from decimal to binary, so exactly what was covered in the video. Let's get started with part 1. Okay, let's start with part 1, which is decimal 4. So step 1, just write down that number, leaving plenty of room underneath. In step 2, we're going to divide that number and write down the result and the remainder. So 4 divided by 2 is 2, remainder 0. Now we're going to do that same step again, but this time with the result we just wrote down. So in this case 2, so 2 divided by 2 is 1, remainder 0. Again, we'll do that step again, but this time with that result we just wrote down, which is 1. So 1 divided by 2 is going to be 0 with a remainder of 1. And now we've got to the end of step 2 because we have a 0 as our result here. So we're on to step 3, and in step 3 we simply write out the remainders starting at the bottom. So we have 1, 0, 0. So 4 in decimal is 1, 0, 0 in binary. And we check we've got it right by converting this binary number we have now back to decimal. So to do that, we draw in columns. We write a 1 above the furthest right hand column. Then we work our way across the columns, doubling each time. So 1 doubled is 2, 2 doubled is 4. And now we just write down any number above a column with a 1 below. So we only have a 1 in this column in this case, so we just write down 4. And that means when we've converted it back to decimal, we still have 4. So we're definitely correct, as these numbers are the same. So 4 in decimal is 1, 0, 0 in binary. So that finishes that one. I'll leave 1.2 for you to do. Let's move on to 1.3, which is decimal 7. So again, we write that down, leaving plenty of room underneath. We divide it by 2 and record the remainder. So 7 divided by 2 is 3, remainder 1. And then we do the exact same thing, but this time on the result we just wrote down. So 3 divided by 2 is 1, remainder 1. And again do the same, but this time on the result we just wrote down. So 1 divided by 2 is 0, remainder 1. And as we've got a 0 as our result, we know we're finished. So now we just write down the remainders starting from the bottom. So that's 1, 1, 1. So 7 in decimal is 1, 1, 1 in binary. Again, we'll convert back. So draw in the columns, do the doubling. So 1, 2, 4. Write down a number above any column that has a 1 below. So that's all of them in this case. So we have 4, 2, and 1. And we add those up. So 4, 5, 6, 7. Again, we have a 7 here and a 7 here, so we know it's correct. So 7 in decimal is 1, 1, 1 in binary. Right, I'll leave you to do 1.4 on your own. Let's do 1.5, so 16. So write down 16. Divided by 2 is 8, remainder 0. 8 divided by 2 is 4, remainder 0. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And 1 divided by 2, 0, remainder 1. And our result's at 0, so we know at the end of step 2. Now step 3, simply write down our remainders starting at the bottom. So 1, 0, 0, 0, 0. So 16 in decimal is 1, 0, 0, 0, 0 binary. And we'll convert back. So again, we only have one of these columns, that's for 16. So our result is 16. They're the same, so we know that's correct. So 16 is 1, 0, 0, 0, 0 in binary. Let's get rid of all this. let's do 1.7. So this one's just decimal 1. So 1 divided by 2 is 0, remainder 1. So that's it. We've got our 0 in a result, so we're finished. So we just start with the remainders. We just write down the remainder starting at the bottom, but we only have 1, which is 1. 1 and 1 is fine. So it's pretty simple, that one. Let's do 1.9, which is 52. So again, we just write down the number and then divide by 2 and write down the remainder. 52 divided by 2 is 26. Remainder 0. 26 divided by 2, 13. Remainder 0. 13 remainder 2 is 6. Remainder 1. 6 divided by 2 is 3. Remainder 0. 3 divided by 2 is 1. Remainder 1. And 1 divided by 2 is 0. Remainder 1. We've got a 0 here, so we know we're finished. So now we're going to write out the remainder starting at the bottom. So 1, 1, 0, 1, 0, 0. So 52 is 1, 1, 0, 1, 0, 0 in binary. And I'll quickly convert it back just to check. So write in the column values, and we've got a 32, a 16, and a 4. So we have 2, carry the 1, and then 5. 52. So we have 52 down here and 52 up here. We know it's correct. So 52 decimal is 1, 1, 0, 1, 0, 0 in binary. Okay, let's get rid of that. Right. We'll just do a couple more of these and I'll leave the rest for you to do. So let's do 1.12, which is 249, 249, 249. Okay, so 249 divided by 2 is 124, remainder 1. 124 divided by 2 is 62, remainder 0. 62 divided by 2 is 31, remainder 0. 31 divided by 2 is 15, remainder 1. 15 divided by 2 is 7, remainder 1. 7 divided by 2 is 3, remainder 1. 3 divided by 2 is 1, remainder 1. And 1 divided by 2 is 0, remainder 1. So as we get to 0, the end of step 2. Now we just need to write out those remainders starting at the bottom. So we have 1, 1, 1, 1, 1, 0, 0, 1. So 249 in binary is 1, 1, 1, 1, 1, 0, 0, 1. Sorry, 249 in decimal is 1, 1, 1, 1, 1, 0, 0, 1 in binary. We can convert that back. It's 1, 2, 4, 8, 16, 32, 64, 128. One's a 1 in, we have 128, 64, 32, 16, 8, and a 1. And if we add those up, we have 9, carry the 2, 4, carry a 1, 2. And so we have 249 down here, 249 up here. We know our conversion is likely right. So 249 decimal is 1, 1, 1, 1, 1, 0, 0, 1 in binary. Just get rid of all this. I'm going to do the last one, which is 1.14. So we have 2072. Again, we just need to follow the exact same steps to get our answer. So 2072 divided by 2 is 1000. 1036 remainder 0. 1036 divided by 2 is 518 remainder 0. 518 divided by 2 is 259 remainder 0. 259 divided by 2 is 129 remainder 1. 129 divided by 2 is 64 remainder 1. 64 divided by 2 is 32 remainder 0. 32 divided by 2 is 16 remainder 0. 16 divided by 2 is 8 remainder 0. 8 divided by 2 is 4 remainder 0. 4 divided by 2 is 2 remainder 0. And 2 divided by 2 is 1 remainder 0. And 1 divided by 2 is 0 remainder 1. We've got a 1 in our result, so we can finish. So now we're going to just write out all those remainders starting at the bottom. So we have 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0. Let's check that's correct. 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0. Okay, and we'll convert it back. I'm going to struggle with fitting my numbers in here. Let's just draw in all those columns. Let's zoom in a bit here. Right. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048. We have 1, 2048, 116, and 18. So we get 2, carry the 2, 7, 0, 2. And we have the same number here and here, so we know it's correct. So we know 2072 in decimal is 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0 in binary. If you can do that conversion, then you'll be able to pretty much do any one. So that brings us to the end of question 1. On to question 2, which is the optional programming question. I'm not going to give a full answer, but I'll leave a link to my basic solution in the description. I will, however, go over some pseudocode. I'll work through the algorithm with an example input so we can see how it works. For this example, I'll use 12. The algorithm has 3 variables. I'll keep track of their current values while working through the algorithm. So the first variable is called number, and it's the input to the algorithm. It's a positive integer, and it's the decimal number that will be converted to a binary representation, represented as a string. This string is the output of this algorithm, and I've named it binary answer. The third variable is called remainder, and it's used to store the remainder temporarily. So on line 1, you can see binary answer is initialized as an empty string. It will be used to build the answer. Now we go on to the main part of the algorithm, the while loop. Previously in this video, I was converting from decimal to binary by hand and had 3 steps. This while loop combines steps 2 and 3. The condition of the while loop checks that number is greater than 0. Well, in this case, it's 12, so we enter the while loop. Just like when we're doing it by hand, we stop step 2 when our result was 0. Well, this loop will stop at the same time. The first line in the loop, line 3, will calculate the remainder. It does this with the modulo operator. If you haven't come across the modulo operator before, it simply gives you the remainder, so exactly what we need. So 12 modulo 2 would give 0. So remainder is now 0. On the next line, line 4, we append remainder to our binary answer. So binary answer would now be 0. On line 5, we divide number by 2 and store it back in number. So 12 divided by 2 would be 6, so number is now 6. And that's the bottom of the while loop. So we start back at the top again and check the loop condition. This time number is 6, so still greater than 0. 6 modulo 2 is 0, so remainder becomes 0. We append that to the binary answer, so binary answer is now 0, 0. 6 divided by 2 is 3, so number is now 3, and we start the loop again. 3 is greater than 0, so we enter the loop. 3 modulo 2 is 1, so remainder becomes 1. We append that to the binary answer, so binary answer is now 0, 0, 1. 3 divided by 2 is 1, so number is now 1. We enter the loop again as 1 is greater than 0. 1 modulo 2 is 1, so remainder is 1. Again, we append that to binary answer, so binary answer is now 0, 0, 1, 1. 1 divided by 2 is 0, so number is now 0. Now this time when we come up to the conditional, we don't enter the loop, as number is now 0, and 0 isn't greater than 0. So now we go on to the last line, where we return the binary answer reversed. Why reversed? Well, if we look at the binary answer string, it's backwards. So in this case, we return 1100, which is 12, which is the correct answer. If we hadn't reversed it, it would return 0011, which would be 3, so wrong. So one thing to consider is if our initial number was 0, what would happen? In that case, we'd never enter the while loop and we'll return an empty string. To get around this, we can use an if statement that checks if number is 0, and if it is, we just simply set binary answer to 0, and that'll be returned. So that's some very basic pseudocode. You should be able to convert it into any language you want fairly simply. There's definitely better ways of doing this, but this one is fairly basic and similar to the process we used while doing it by hand. If you have any questions, please leave a comment and I'll try and answer it. Thank you for watching, and look out for the next video, which will cover binary arithmetic.